show that the resistor R2 has a resistance of 40 ohms. So as we just figured out in question C, the voltage across this loop here is in fact 8 volts. Because the voltage across this resistor here is 2 volts, and the supply voltage is 10, so 10 take away 2 is 8, so that voltage across here is 8 volts, and the voltage across here must also be 8 volts. So the first thing we need to do to show that that resistance R2 has a value of 40 ohms is to work out the current. And we're simply going to use the same formula we used in question C, power equals IV. We're going to rearrange it just like we did in C to make I equal P over V, because the current going through the light bulb is the same as the current going through the resistor, because these two are in series. Okay, so we know that the power output of this light bulb is 0.3 watts, and the voltage it's running at is 6. Come over to the calculator, 0.3 divided by 6 gives us a current of 0.05 amps. So we know there is a current of 0.05 amps going through the light bulb and through the resistor. We know there's 8 volts across both the light bulb and the resistor, and since the light bulb has 6 volts across it, that must mean that the resistor has 2 volts across it. Now we know the voltage across the light bulb, we know the current going through the light bulb. We can simply use Ohm's law, V equals IR, to determine the resistance of the resistor, where R equals V divided by I, which equals 2 volts across the resistor divided by 0.05 amperes, 2 divided by shift answer gives us our resistance of 40 ohms. Question 2e. Show that the resistance of the resistor R1 up the very top here is 16 ohms. In order to find out what the resistance of this is, we need to know what the current going through that is. And since it's in series with a power supply, we know that the current going through R1 is going to be equal to the current that's coming out of the power supply. So we simply need to add up the current that's going through this bulb and the current that's going in this circuit, and that'll give us the current that's going through R1. So if we look at our answer to D, we see that the current going through R2 is 0.05 amps. So the total current is going to be 0.05 amps plus our answer to C, which says that the current going through bulb A is 0.075 amps. 0.075 amps. Chuck that in the calculator. 0.05 plus 0.075 gives us a current of 0.125 amperes. So to find out the resistance of R1, we know the voltage, we know the current, we simply use Ohm's law, which is V equals IR, and we're looking for the R, so we rearrange this to be R equals V divided by I. The voltage across that resistor is 2 volts, the current going through the resistor is 0.125 amps, so the resistance is 2 divided by answer, making it 16 ohms.